Welcome to Think Energy, a podcast that dives into the fast-changing world of energy through conversations with industry leaders, innovators, and people on the front lines of the energy transition. Join me, Trevor Freeman, as I explore the traditional, unconventional, and up-and-coming facets of the energy industry. If you have any thoughts, feedback, or ideas for topics we should cover, please reach out to us at thinkenergy@hydroottawa.com.
Hi, everyone, and welcome back. Today's episode brings us back to a few elements of my own personal history. Now, you'll have to bear with me for a minute or two while I dive into my past in order to properly set up today's conversation. I grew up in Southwestern Ontario, in and just outside the border town of Windsor, Ontario. Now, for those of you not familiar with this area, Windsor and its surroundings are the most southern part of Canada. It might surprise you to know that Windsor is at the same latitude as Northern California and Rome, Italy. You can imagine that after growing up in Windsor and then living in various places around the globe, when I finally settled down here in Ottawa, adjusting to the more stereotypical Canadian winters of this northern capital took a little bit of getting used to. Windsor is so far south, when you cross the border to its neighboring American city, Detroit, Michigan, you actually travel north. Have a look at a map if this seems to defy logic, but I promise you it's true. This is the area that I grew up in. It's also where I went to school and got my engineering degree. More on that in a minute. Now, if you've ever driven down to the southwestern end of the 401, going past London and Chatham, you will notice two things. First, it is flat, very flat. You will not see a meaningful hill anywhere in sight. I often joke with people that I used to toboggan when we did get any meaningful snow off of highway overpasses because that was the only hill we could find. I was only partly joking, and I have indeed tobogganed off of said overpasses in my young and foolish days, but that is a story for another time. That brings us to the second thing you'll see, which is wind turbines. A lot of wind turbines. They are seemingly everywhere, stretching as far as you can see. Southwestern Ontario is a hotbed of wind energy generation. Finally, a hint at why I'm going on about this part of the province on an energy podcast. But before we get into it, there's one other thing to touch on, and that is the fact that this area is also home to a large number of greenhouses growing produce year-round, as well as manufacturing. Windsor and its surrounding area is the automotive capital of Canada, with a number of plants from major car companies, as well as a supporting ecosystem of parts manufacturers. Incidentally, that's where I started my career, working as an environmental engineer for one of the automakers. And many members of my family have also worked or still work in that industry. The reason I bring up greenhouses in the auto industry is because they have some very high energy demand profiles. And that is how we get from me going on nostalgically about the area I grew up in to our conversation today. I recently caught up with one of my engineering professors, Dr. Rupp Carriveau, about the work that he and his colleagues have been doing that ties all of this together, and I thought it would be great to have him on the show to talk about that. Dr. Carriveau is the director of the Environmental Energy Institute and co-director of the Turbulence and Energy Lab and the co-lead of AgUWin at the University of Windsor. Back in the day, he was my fluid dynamics professor, but today he balances his teaching duties with research into energy systems futures and advanced agricultural systems. He is a founder of the Offshore Energy and Storage Society, a recipient of the University Scholar Award, and has been named to Canada's Clean 50 for his contributions to clean capitalism. Dr. Rupp Carriveau, welcome to the show.
Trevor, great to be here. Thanks.
Yeah, so Rupp, the last time we chatted, you and I chatted a couple weeks ago, but before that, the last time that you and I interacted, I was in third year university. You were my fluid dynamics prof. So in addition to your professorial duties, you're now the director of the Environmental Energy Institute at the University of Windsor. So there's two questions around that. First off, how did you end up going from, my fluid dynamics prof a number of years ago, probably close to 20 years ago now, to running this institute? And tell us a little bit about what the institute does.
Sure. So thanks. Yeah, and very memorable, Trevor, because I remember you well, and yeah, that was a very nice class that we had. I remember your colleagues too.
If there's one thing I do well, it's be memorable, and that you can
Well,
take that however you want.
That is something to be said for that. Yeah, thanks for that question. So I should point out that in addition to EEI, I am a co-director in the Turbulence and Energy Lab, which is really where all of the EEI initiatives have started from. That's a lab that I co-supervise with Dr. David Ting in mechanical engineering. And the nuts and bolts, the very serious engineering side of things comes out of the Turbulence and Energy Lab. EEI kind of came about to handle topics that were, frankly speaking, less interesting to Dr. Ting. So things that push more, a little bit more into policy, wider systems looks at things, as opposed to, pure thermodynamics and energy efficiency type pursuits, which underpin a lot of the EEI policy pieces, but are sort of beyond the scope of what Turbulence and Energy Lab does. So those two things, and then more recently, actually, I'm a co-lead on Ag-U-Win, which is like a center of excellence, emerging center of excellence at the University of Windsor. So Agriculture U Windsor is a group of about 40 professors that do work in agriculture in some shape or form. And we've we've taken to organizing that movement in seeking sort of group funding proposals, developing curriculum, and organized sort of platforms to help industry in agriculture. And it's really taking off, which I'm really excited about. My extremely hardworking colleagues and co-lead, Isabel Barrett-Ing, she in particular has been really driving a lot of really cool initiatives ahead, and all the people that work with us. So yeah, lots happening at the university since I saw you last, but time has a way of helping with that. People find ways to find efficiencies and get to do and build on hopefully incremental progress.
Yeah, very cool. And you're teasing a few of the areas our conversation is going to go today, that sort of intersection between agriculture and, obviously, this is an energy podcast. And so how does agriculture and the way we're moving in with agriculture impact energy, and vice versa? So we're definitely going to get to that in a minute. I think for our listeners that are not familiar with Southern Ontario, and I haven't talked about Southern Ontario on the podcast a lot, but people that know me know I will gladly talk about what goes on in the very southern part of our country. It's where I grew up. Help us paint a picture of what Southern Ontario is like. So, in the context of energy, what makes this area of Ontario unique?
Well, that's a really good question, and I'm glad you phrased it that way, because I think it gets taken for granted, and also folks don't know energy isn't in the headlines every day, and if it is, it's not a headline that everybody pays attention to. But the Southwestern Ontario region, if you take the 401 west of London, you'll start to see a high concentration of wind. So there's a significant wind corridor in the region, and that's because it's very flat. So the whole area used to be a lake bed, and so we have very fertile agricultural lands as a result of that. And we also have very few obstacles to fetch, which is a huge aspect of how wind carries over the lakes and is not obstructed. And so it's like you have offshore resources onshore, which is completely ideal. Um, Also, we have, as it may be, we have massive natural gas resources in the area, in sort of the subterranean space of Devonian reefs for natural gas storage. We have natural gas generation facilities down around the Windsor area that help with provincial peaking. And there is some solar in the region, because it is the Leamington Kingsville area is referred to as the sun parlor of Ontario, and as a result, we have a lot of underglass agriculture there, which benefits obviously directly from solar resources, and then we have solar photovoltaic that takes advantage of that sun as well. So there's a lot happening here energy wise.
Yeah, and there's a lot on the demand side of things as well. So you mentioned the greenhouses, which are an up and coming, source of demand draw on our grid. There's also a big manufacturing base. Talk a little bit about the manufacturing base in the area.
Yeah, thanks. So yeah, I was thinking about generation, and yeah, demand is significant. We have Windsor has laid claim to Canada's automotive capital, and while I'm biased, I'd like to think it still is. Um, and so we have significant manufacturing around the automotive industry, either um, automotive OEMs or tier one parts makers that have significant draws. We have Stellantis. Every minivan comes out of this area, has come out of this area. The electric Dodge Charger comes out of this area. Um, but there are engine plants for Ford, but there are also now, sort of next generation transport technologies. You're talking about battery manufacturing. So there's an enormous LG consortium with Stellantis here that's doing battery manufacturing. And so these are huge loads that add to existing and growing loads in the greenhouse space, which again, I'll just mention it now, is something that isn't well understood. And we did a study for the province a couple years, 3, 4 years ago now, I think, Grid Innovation Fund project that looked at sort of really getting into granular detailing of the loads that come with a lit greenhouse. A lot of people don't appreciate that a lit greenhouse, when switched on, depending on the lighting technology, depending on how it's used, can be like a 50 megawatt load, which is a significant load. And just imagine that's one. So they can come on quickly and they are non-trivial, significant loads. And so this is something that we looked at trying to develop distributed energy resource sort of solutions for, because simply speaking, you can't put up a new transmission line overnight. And we don't want to economically constrain the growth of the sector.
Yeah. Yeah, and that gets into my next question, is talking about some of the specific unique energy needs of greenhouses. I think on the manufacturing side, you mentioned the auto industry and the parts industry that supports it. You're seeing more. There's a battery plant being built now, I think. That I think people have a sense of that, but greenhouses is this thing that I think a lot of folks don't think about. So you talked about the magnitude of the load, the lighting side of things. What else? Is this like a 24/7 load? Is this sector growing? Like, tell us a little bit about, where things are going with greenhouses.
Sure. Yeah. I mean, it's not a simple thing to characterize, because what you can take away from this is that these greenhouse developers are business dynamos. And frankly speaking, many of them do very well, because they're very good at what they do. And with the resources they have, they can largely do what they want. And if the infrastructure isn't there, they will build it. So you'll have folks that are operating off the grid, essentially not off the gas grid, of course, but they're using gas for cogeneration purposes to produce heat for their crops, but also the electricity for their lights. So that is one aspect of it that further complicates how to figure out what these loads on the grid will be. But for the most part, of course, the grid provides quite clean and quite affordable electricity in the province. And, where they can, they want to be able to connect to the grid. Now, lights are designed to extend the growing day and extend the growing season as well. So, in terms of when they're switched on and how they're switched on, that is highly variable. And that is also something that is, I would say, in development. Folks are looking at different ways to use intermittent lighting to be conscious of when peaking happens. Um, it is dispatchable in a way in that some growers are able to turn their lights off to avoid, peaking charges. But again, there's a lot to manage, and it's very complicated both on the grid side and for the greenhouse grower.
Yeah. So you mentioned natural gas for cogen, for heating as well. So as we look to decarbonize all different aspects of the sector, we talk often on the show of what are the specific areas where decarbonization might be challenging. Is greenhouses one of those areas, and what are the options available for heating these spaces? Like, is it realistic to think that there's an electric solution here, or what's happening in that sector related to decarbonization?
Again, you've hit on a real sort of hot button issue for the sector. Um, the trouble with natural gas is that it's spectacular.
Hmm.
Oh, it's it's storable, it's dispatchable. It's a triple threat for greenhouses in the best way possible because you can make your heat, you can make your electricity, and the plants crave CO2, and that comes out of the flue gas on the other side of the combustion reaction. So, when you swing in there and you say, "Oh, I've got this great new solution. It's called hydrogen. We'll burn hydrogen and we won't have this nasty CO2 release." And they're like, "Okay, who's going to replace my CO2?" So it's a difficult fuel to displace. Now, admittedly, people understand that that's where we really need to go. And is electrification the the path? So people talk about heat pumps, people talk about electric boilers, and then as I mentioned, people talked about we've also looked at the idea of blending hydrogen into a natural gas feed for existing infrastructure to because not all of the CO2 that is released is taken down by the plants. And so could you get to a magic blend where it's just the amount of CO2 that you need is what goes into the other side, and then there's nothing left after the plants take what they need? So there's a lot of things that are being looked at. It is, again, a challenging space to operate in because it's highly competitive. Getting really granular data is very sensitive, because this is it's a game of margins, and it's high stakes production. So to get in there and sort of be in the way is difficult. So this work is being done. We're participating in a lot of this work. We just finished a study for the province, a hydrogen innovation fund study on looking at the integration of hydrogen into the greenhouse space, and it was pretty revelatory for us.
So is the exhaust from burning natural gas on site, does that get recycled through the greenhouse and therefore captured to some degree? Do we know how much? You kind of hinted at finding out that sweet spot. Do we know how much of that gets captured?
Yeah, so the short answer is yes. So they have the cogen engines have scrubbers on them, and they can and these machines are spectacularly capable of being tuned to the combustion, and the professionals that operate them at the greenhouse facilities are artists, and that they can get the sort of combustion profile a certain way, and so that flue gas will go into the greenhouse. But to know exactly how much is being taken down, that is an area of active research, and we don't know that answer yet. There are people that are looking at it, and you can imagine it's kind of a provocative number for the sector. So they're doing it. They're being very careful about how they do it.
Yeah, I'm sure. I'm sure. Okay, let's park that just for a minute here and jump back to something you mentioned earlier. You talked about one, how flat Southern Ontario is, and it took me leaving the county before I really knew what skiing and tobogganing and everything else was. So there's a lot of wind power generation, and for anyone listening, yeah, as Rupp mentioned, if you ever drive down the 401 going towards Windsor, you'll just start to see these massive wind turbines kind of everywhere you look. So help us understand how these turbines, you look out over a field and you see, you know 20, 30 of them, more in your line of sight. How do they connect to our provincial grid? How do the contracts work? Like, who gets that power? Give us a little bit of a sense of how that works.
For sure. Yeah. Well, so what most people don't realize, and again, it's not something that's talked about, and if it is, I don't know if people are necessarily paying attention to it, but you know, the comment I'll get from relatives, we talked about Thanksgiving. So, people because they know I'm a wind person, they'll be like, "Hey, I was driving down the road and I saw they weren't spinning. What's going on? What's going on?" Are they broken or what? What are they, because we've got some pro wind and some non-pro wind folks in the family. So it's an exciting time for me. But and I mentioned that the greenhouses I'm working with are often starved for utility supply. And they said, well, how can that be? The turbines are right there. They're sharing the same space, right? And most people don't realize that really, I would say 95% of the wind in our corridor is put on a transmission line and sent up to effectively to Toronto to be distributed throughout the province, which is great, but it's not really a local asset. Um, and that was sort of what inspired us when we saw these two sort of juxtaposed. We thought maybe you could turn these assets into something that acted as really a a new type of distributed energy resource, and that you've got a transmission connected asset that's currently under contract. But if that contract could be modified, then the physical connections could potentially be modified. So you could have local distribution, let's say at a time of transmission curtailment, um, maybe under different conditions. So again, looking into the physical plausibility of it was part of our study, and then doing some sort of economic investigation of how that would work. Having a nearly 20-year-old asset all of a sudden springing into a new role and a new life where it continues to perform transmission duties for the province at large, but it also serves local needs in the production, let's say, of hydrogen through an electrolyzer or just plain electrons turning lights on. That is something that isn't possible yet. Regulatory reasons exist for that require some significant changes. But it was a really interesting exercise to go through to investigate how that could happen.
Yeah, so there's just trying to understand how these work. There's someone owns these turbines, some conglomerate somewhere, Canadian, not Canadian, who knows. They contract with the independent electricity system operator who operates the grid in the province. And they basically say, yeah, well, look, we'll provide you with X amount of power on some contract. And when ISO needs it, they call on it. How long do those contracts last? Is that a 10-year contract, a 20-year contract?
So they are in Ontario, the ones that I'm familiar with are 20 years. So it's possible there are others. I know there's a farm that operates in PEI that has a nice 30-year PPA. So the longer you can get, the better, the better, of course. Yeah, and these power purchase agreements are wonderful for developers because they're known entities. Doing the math on your finances is really straightforward with these contracts. And frankly speaking, when you had a sector that needed to be brought up from nothing, they were very necessary.
Mhm.
They were very necessary. But those contracts and they're locked down. As much as we try to uh persuade the province to get crazy to amuse us with these newfangled ways of connecting to people commerce wise through energy, they are not interested so far, at least in that. And they're like, let's finish these out, and then we can talk your crazy ideas. But we're getting there because I would say many, many, many farms in the province will be coming up on the sunsetting end of their power purchase agreements in the coming 5, 6 years.
Yeah. Yeah. Which brings me to my next point of the assets themselves, the actual physical turbine, I assume lasts longer than 20 years. You're going to build one of these things that, 20 years is not its end of life. So what are the options available today? You talked about regulatory barriers. We talk about regulatory barriers on this show often. What are the options today for a wind farm that is at its end of contract? Does it look at recontracting? Can it kind of direct source to someone else? Like, what are the options available for an owner?
Yeah. Well, to me, it's an exciting time because it could be work for us. We get excited about this. I think it could be a source of anxiety for owners because there's nothing better than that long-term contract. So many of them will try to apply for things like a new medium term length contract from the province, like an MT2, I think they're called. There are other contract types that are possible, but it'll be a highly competitive landscape for those. And the province won't be able to give everyone one of these contracts. So some of these operators will likely have to look at other options, which may be going into the spot market, potentially, getting into the capacity game by getting a battery on site and firming up their ability to provide power when necessary or provide capacity. And then there is a relatively recent regulatory development around the middle of July. The province said, if you're a non-emitting generator and you're not under contract, you could provide virtual power to someone else who might need it if they're a Class A customer that's trying to avoid peak charges. Rather than that Class A customer buy a battery behind the meter and physically reduce their peaks, they could potentially virtually reduce their peaks by setting up a virtual power purchase agreement with another supplier. So these off contract spinning assets could have an opportunity to get into this game of peak relief, which could be very lucrative because based on last year's provincial global adjustment charges at large, you're looking at being paid something on the order of about $72,000 a megawatt hour for the megawatt hours in question, which of course, try to get as many as you can.
Yeah, so there's a couple things there. Bear with me while I connect a few dots for our listeners. So on different shows, we talk about different things. Global adjustment is one of them, and we've been talking here about these long-term contracts. Global adjustment, as you might remember from previous conversations, is one of those mechanisms that bridges the gap between the spot market price, the actual commodity cost of electricity that's out there, and some of the built-in costs to run the system, which includes these long-term contracts. So there's a fixed cost to run the system. Global adjustment helps bridge that gap. The next concept here that is important to remember is this Class A strategy, where the largest customers, electricity customers in the province, have the opportunity to adjust how they are billed global adjustment based on their contribution to the most intensive demand peaks in the province over the course of a year. So during a really high demand period when everybody needs electricity, if they can reduce their demand, there's significant savings. And so what you're saying is there's this new ability for kind of a virtual connection where if I'm a big facility that has a high demand and I contract with a generator like a wind turbine that's not in contract anymore, I can say, hey, it's a peak time now. I need to use some of your capacity to offset, some of my demand. And there's those significant savings there. So you're absolutely right. That's a new thing in the province. We haven't had that ability up until just recently. So super fascinating. And that kind of connects our two topics today, the large demand facilities in Southern Ontario and these generators that are potentially nearing the end of their contract and looking for what else might happen. So are you guys navigating that conversation between the greenhouses or the manufacturers and the generators?
I'm so glad you asked. And here comes a shameless plug.
Yeah.
So yes, so there's a spin-off company from the Turbulence and Energy Lab, and it's called Jailbreak Labs. And Jailbreak Labs really represents sort of the space that is more commercial than research, but it was sort of spurred from research. Um, so Jailbreak Labs has developed a registry, and we've been providing some webinars as well. So this is a company that is essentially run by students. That this registry allows generators and consumers to ultimately find each other, so that these kinds of connections can be made. Because as you may well imagine, there is no guarantee that the wind will be blowing at the time that you need it. And your load may be such that you need a different type of generation profile. So there needs to be profiling on the generation side. There needs to be profiling on the customer side. And, we've been doing this on our own for years. The time was right for us to sort of step in and say, because we were following this, we were real fanboys of this reg even before it came into play. And we kept bugging, OEB for meetings and ISO, and they begrudgingly, to their credit, would chat with us about it. And then the next thing we know, it's announced that it's happening. It was very exciting. So yes, so we're really interested in seeing this happen because it seems like such a unique. We're thrilled because we're always interested in this sort of second life for assets that already have been depreciated, and they're clean energy assets. Let's get everything we can out of them, and to have this dynamic opportunity for them, and that will help Class A customers. Too hard for us to ignore.
Mhm. And you mentioned the last time we chatted about building a tool that helps evaluate and kind of injecting a little bit of AI decision making into this. Talk to us about that tool a little bit.
Yeah, so we have a tool called Quantract, which is basically playing on the idea of quantifying uh, all the risk and opportunity in a contract. So it's really a contract visualization tool. Another way to think of it is a real-time net present value uh, tool that allows renewable energy stakeholders to really uh, evaluate the value of their investment by not only understanding the physical life left in an asset. Let's say that a wind farm that's, at 20 years, and it looks like we may need to replace some blades. Do we just walk away and say, "Look at it, we had a good run. Um, Contract's over, we made some money, let's sell the assets as they are." Or do we say, "I'm looking into this VPPA game, and we could do okay here, but I'm not exactly sure how that's going to work and when." And so this tool that we've developed will do things like, will, first of all, identify all risk factors, and risk includes opportunities. Um, and then we'll profile them, and then builds them into basically what is more or less a glorified discounted cash flow model. So it is a way of measuring the potential value of investment. In the AI space, the AI piece of it is that we have developed agents that will actually identify other things that are less sort of noticeable to people. In fact, this regulatory change is one of the things that our AI agents would have been looking for. Okay, now it predated our tool going online, so we didn't see it. But it's the kind of thing that we'd be looking for. So the agents look for news, they look for changes online, and then what happens is they get brought into a profiler. The profiler then determines the probability of, or makes an estimate of the probability that this risk will occur, i.e., a regulatory change will happen, i.e., a battery plant will come to town at a certain time, i.e., a Costco facility will come in. Then we'll determine the potential magnitude. So there'll be uncertainty in the occurrence, there'll be uncertainty in the magnitude, and there'll be uncertainty in the timing. So we have basically statistical distribution functions for each one of those things: the likelihood of it happening, the magnitude, and the timing. And so those are all modeled in so that people can push a button and say, with this level of certainty, your investment would be worth this much. And that's dynamic. It's in real time. So it's changing constantly. It's being updated constantly. And so that is something that goes in. And one of these virtual power purchase agreements would be one of the types of things that would go into this sort of investment timeline.
Yeah. So it's giving these owners of these assets better data to make a decision about what comes next, as you said. And as we're talking, I'm kind of doing the math here. If these are typically 20-year contracts, that's bringing us back to, the mid early 2000s when we were really pushing to get off coal. So a lot of these assets probably started in and around that time. So you've probably got a whole bunch of customers, for lack of a better term, ready to start making decisions in the next, half a decade or so of what do I do with my assets? Have you seen this? Has it been used in the real world yet, or are you getting close to that? Like, where are you at in development?
Yeah, it actually started. It's funny. It started a little bit even before this craze. A couple of years ago, we had a manufacturer in our county come to us with. They had a great interest in just um, they were trying to be proactive about avoiding carbon tax. And they wanted to develop a new generation technology close to their facility. And so we used it there. Um, since that time, yeah, so it was field proven. That was still a research contract because the technology that they were interested in was not off the shelf. Um, but since that time, we got a chance because we represent Canada in the International Energy Agency Task 43 on wind energy digitalization. And so one of the mandates there was to develop robust and transparent tools for investment decision support using digital twins. And we had a German partner in Fraunhofer Institute that had developed a nice digital twin that would provide us remaining useful life values for things like blades, towers, foundations, etc. And those are all costs that just plug into but they didn't have a framework of how to work that into an investment decision. Other than, you may have to replace this in 3 years. Okay, well, that's good to know, but we need the whole picture to make that decision, and that's sort of what we were trying to bring. So the short answer is yes, we're getting a lot of interest now, which is thrilling for us. But I'll be honest with you, it's not simple. Like, I've talked about it a bunch of times, so I'm pretty good at talking about it, but the doing it is still it's computationally intensive, and in the end, it's still an estimate. It's a calculated, quantified estimate, but it's an estimate. I think what we like about it is it's better than saying, "Well, I have a hunch that it's gonna go this way," but we could get beat by the hunches too,
Yep. Yeah, totally.
right? So, I'm not trying to sell people things um, like we have to be transparent about it. It's still probability.
Well, I think if there's one thing that is very apparent as we are well into this energy transition process that we talk about all the time here on the show, it's that the pace of change is one of the things that's like no other time. We are seeing things change, and that means both our demand is growing, our need to identify solutions is growing, the way that we need to build out the grid and utilize DERs and utilize all these different solutions is growing at a rate that we haven't seen before, and therefore uncertainty goes up. And so to your point, yeah, we need help to make these decisions. We need better ways of doing it than just, as you say, having a hunch. But that doesn't mean it's foolproof. It doesn't mean it's a guarantee.
Nope, it is not a guarantee.
Very cool. So, Rip, this is a great conversation. It's really fascinating to talk about. To me, two areas of the energy sector that aren't really understood that well. I think the agriculture side of things, not a lot of people think about that as a major demand source. But also wind. I think we talk about solar a lot. It's a little bit more ubiquitous. People's neighbors have solar on their roofs, but wind is this, unless you drive through Southern Ontario or other parts of the province where there's a lot of wind, you don't see it a lot. So it's fascinating to kind of help understand where these sectors are going. Um, is there anything else that the Institute is working on that that's worth chatting about here? Or is what we've talked about, kind of filling your day in your students' days?
Well, there is something. We haven't talked about the nuclear option. No,
Literally the nuclear
literally the nuclear option. Um, yeah. So we've been really thrilled to have a growing relationship with Canadian Nuclear Laboratories, which is much closer to you than it is to me.
option.
Um, and specifically in the connection of small modular reactors to meet these growing agricultural loads. So I have a science colleague at the University of Windsor, Dr. Drew Marquardt, who was all hot and bothered about these SMRs, and he's like, "We should drop one of these SMRs in Leamington." And I said, this part I really enjoyed because obviously, so he came from Oak Ridge National Laboratories in the States, and he's been at CNL as well. So he's fully indoctrinated into the nuclear space, but it just didn't occur to him that that would be provocative or controversial at all, that there wouldn't be some social. He's like, "We can do the math." And I said, "Oh, yeah, yeah, we can do the math." But I'm like, "I think you're missing something." Like, I think you're missing something, right? So it's a super fascinating topic, and we're trying to physically connect. So just before the weekend, I was in the Turbulence Energy Lab, and we were trying to commission what we believe is North America's first, we're calling it a model synthetic small modular reactor. Synthetic being the key word in that it's non-nuclear.
Okay.
And so it's non-nuclear. What it is really, and if I'm going to de-glamorize it for a second, it's a mini steam thermal power plant, which doesn't embody every SMR design, but many SMRs are designed around this sort of where you've got a nuclear reaction that provides the heat, and then after that, it's kind of a steam thermal power plant. Our interest is in this physical little plant being connected to small electrolyzer, being connected to small thermal battery, being connected to a lab scale electric battery, and being connected to a lab scale, fully automated, inlet small cucumber greenhouse, mini cubes greenhouse. All this in our lab. The exciting thing around this is, you know, I've said that I think nuclear technology needs to get out from behind the walls of nuclear facilities for people to start to appreciate it. And by that, to start doing that, you have to take the nuclear part out, which to me is not necessarily a deal breaker in terms of these dynamic issues that we want to solve, because nukes have traditionally been said, well, they're not that, you can't just ramp them up and down. And that's true, and small modular reactors are supposed to be considerably more nimble, but there's still lots of challenges that have to be solved in terms of how does an asset that provides copious energy, but does so maybe not as dynamic, certainly as a gas turbine, that how do you make it nimble, right? How do you partner it up with the right complementary other grid assets to take advantage of what it does so well, which is crank out great amounts of heat and electricity, so effortlessly, right? And so that's sort of what we're trying to do, and connecting it to what we're calling atomic agriculture. I don't know if that's a good name or not,
I know, I like it. I like it a lot.
but yeah, so that's another thing that we're flirting with right now. We're working on. We've had a few contracts with Canadian Nuclear Laboratories to get us this far. We did everything computationally. We're continuing to do computational studies with them. They developed their own hybrid energy systems optimizer software, HESO, which we use, and we are now trying to put it into sort of the hardware space. So again, just the idea that physically looking at the inertia of spinning up a turbine, the little sort of steam powered turbine that we have in the lab that's run by an electric boiler. But our hope is to ultimately we're going to get the electric boiler to be mimicking the sort of reaction heating dynamics of a true reactor. So but through electrical control. So we'll imitate that by having sort of data from nuclear reactions, and then we'll sort of get an electrical signal analog so that we can do that and basically have a non-nuclear model small modular reactor in the lab.
Very cool. Very neat. Well, Rupp, this has been a great conversation. I really appreciate it. We do always end our interviews with a series of questions here, so I'm going to jump right into those. What's a book that you've read that you think everyone should read?
I would say any of the Babysitters Club. That's as high as I get in the literary hierarchy. I'm barely literate, so and I thoroughly enjoyed reading those books with my daughters. Thought they were great. So I recommend any of the Babysitters Club titles. I mean that completely seriously. That was the peak of my that or Dogman.
Yeah. I'm about 6 months removed from what I think was about an 18-month run where that's all I read with my youngest kiddo. So they've just moved on to a few other things, but yes, I've been steeped in the Babysitters Club very recently. So
Good. So
absolutely. So same question, but for a movie or a show, what's something that you recommend everyone?
thrilled with that question. If you're looking for a good true story, I've always been romantically obsessed with the Ghost in the Darkness, the true story of I guess a civil engineer trying to solve a problem of man-eating lions in Savo. That's a tremendous movie with Val Kilmer and Michael Douglas.
Yeah, that's a good
And
one.
then and I think for something a little more lighthearted and fun, big fan of The Way Back and um and Youth in Revolt.
Nice. I love it. If someone offered you a free round trip flight anywhere in the world, where would you go?
I don't really like flying, I gotta be honest. Uh, but if I was forced onto the plane, I think I'd go to Japan.
Nice. Have you been before?
No, I haven't, and I'd like to go.
Okay, cool. You're not the first guest that has said that. Someone else was
Yeah,
very
that's
interested in
that's
going.
understandable.
Yeah.
Yeah.
Who's someone that you admire?
I would say truly selfless people that help people, when no one's looking and when it's not being tabulated for
Mhm.
likes. Those people are who I aspire to be more like.
Nice. And last question, what's something about the energy sector or its future that you're really excited about?
I think maybe power to the people. I really like the movement of distributed energy resources. I'm sure there's a limit to it, but I think if we have more responsibility for our own power production, and again, I concede there are limits where it's probably, uh, you know, there's a point where it's too much. I'm all for major centralized coordination and the security and the reliability that goes with that. But I think a little bit more on the distributed side would be nice because I think people would understand energy better. They would own it more, and I think our grid would probably increase in its resiliency.
Yeah, that's definitely something that no matter the topic, it seems is a part of almost every conversation I have here on the show. It works its way in, and I think that's indicative of the fundamental role that decentralizing our energy production and storage is already playing and is going to play in the years to come as we kind of tackle this energy transition. Dr. Rupp Carriveau, this has been a really great conversation. I appreciate you taking the time to talk to us, and it's great to catch up. Great to chat with you again.
Total privilege for me, Trevor. I really appreciate it. Outstanding job. Thanks for having me.
Yeah, great to chat. Thanks for tuning in to another episode of the Think Energy Podcast. Don't forget to subscribe wherever you listen to podcasts, and it would be great if you could leave us a review. It really helps to spread the word. As always, we would love to hear from you, whether it's feedback, comments, or an idea for a show or a guest. You can always reach us at thinkenergy@hydroottawa.com.